Solar flares are large eruptions of electromagnetic radiation from the sun lasting from minutes to hours. The sudden outburst of electromagnetic energy travels at the speed of light. Therefore, any effect on the sunlit side of Earth's exposed outer atmosphere occurs at the same time the event is observed. The increased level of X-ray and extreme ultraviolet radiation results in ionization in the lower layers of the ionosphere on the sunlit side of Earth. They can wreak havoc on the satellite-based navigation and communication system. The cosmic ray and radiation also have a negative impact on our human body. X-rays and UV radiation emitted by solar flares can affect Earth's ionosphere and disrupt long-range radio communications, the operation of radars, and other devices that use those frequencies. Though it has large impact on our lives, scientists are unable to forecast flares. The source of a flare's energy and the mechanisms involved are still not well understood. Flares occur when accelerated charged particles, mainly electrons, interact with the plasma medium. Evidence suggests that the phenomenon of magnetic reconnection leads to this copious acceleration of charged particles. On the Sun, magnetic reconnection may happen on solar arcades, which is a series of closely occurring loops following magnetic lines of force. These lines of force quickly reconnect into a lower arcade of loops, leaving a helix of magnetic field unconnected to the rest of the arcade. The sudden release of energy in this reconnection is the origin of the particle acceleration. The unconnected magnetic helical field and the material that it contains may violently expand outwards, forming a coronal mass ejection. This also explains why solar flares typically erupt from active regions on the Sun where magnetic fields are much stronger. But it's still not clear how the magnetic energy is transformed into the kinetic energy of the particles, nor is it known how some particles can be accelerated to the giga-electron volt range and beyond. There are also some inconsistencies regarding the total number of accelerated particles, which sometimes seems to be greater than the total number of coronal loop. According to the energy they emit, solar flares can be classified into five categories such as A, B, C, M, and X. These are measured at the Earth by GOES spacecraft, which is Geostationary Operational Environmental Satellite. The strength of an event within a class is noted by a numerical suffix ranging from 1 to 9, which is also the factor for that event within the class. Hence, an X2 flare is twice the strength of an X1 flare, and an X3 flare is 3 times as powerful as an X1 flare and only 50% more powerful than an X2 flare. Though flares cannot be predicted, they come more or less in a cycle known as solar cycle. The solar cycle or solar magnetic activity cycle is a nearly periodic 11-year change in the sun's activity. Generally speaking, with each cycle, the sun's north and south poles trade places. Levels of solar radiation and ejection of solar material, the number and size of sunspots, solar flares, and coronal loops all exhibit a synchronized fluctuation from active to quiet and to again active with a period of 11 years. This cycle has been observed for centuries by changes in the sun's appearance and by terrestrial phenomena such as auroras. The most recent cycle is known as Cycle 25. It has started in the last quarter into 2019 and is ongoing. It is the 25th cycle since 1755. It is expected to peak at mid-2025. The sun is shrouded in mystery. We will continue to learn more about our sun in the next videos. Thanks for watching. Please like, comment and share this video. To see such videos in future, please subscribe.